In this video, I want to give you the basics of trigonometry. Trigonometry. And it sounds like a very complicated topic, but you're going to see that it's really just the study of the ratios of sides of triangles. The trig part of trigonometry literally means triangle, and the metry part literally means measure. So let me just give you some examples here, and I think it'll make everything pretty clear. So let me draw some right triangles. Let me just draw one right triangle. So this is a right triangle. When I say it's a right triangle, it's because one of the angles here is 90 degrees. This right here is a right. That right there is a right angle. It is equal to 90. It is equal to 90 degrees. And we'll talk about other ways to show the magnitude of angles in future videos. So we have a 90-degree angle. It's a right triangle. And let me put some lengths to the sides here. So this side over here is maybe 3. This height right over there is 3. Maybe the base of the triangle right over here is 4. And then the hypotenuse of the triangle. The hypotenuse of the triangle over here is 5. You only have a hypotenuse when you have a right triangle. It is the side opposite the right angle, and it is the longest side of a right triangle. So that right there is the hypotenuse. Hypotenuse. You probably learned that already from geometry. And you can verify that this right triangle, the sides work out. We know from the Pythagorean theorem that 3 squared plus 4 squared has got to be equal to the length of the longest side. The length of the hypotenuse squared is equal to 5 squared. So you can verify that this works out. This satisfies the Pythagorean theorem. Now, with that out of the way, let's learn a little bit of trigonometry. So the core functions of trigonometry, we're going to learn a little bit more about what these functions mean. There is the sine function. There is the cosine function. And there is the tangent function. And you write sine, cos, or sin, cos, and tan for short. And these really just specify for any angle in this triangle, it'll specify the ratios of certain sides. So let me just write something out. And this is a little bit of a mnemonic here. So something just to help you remember the definitions of these functions. But I'm going to write down something. It's called Sohcahtoa. Sohcahtoa. And you'll be amazed how far this mnemonic will take you in trigonometry. So we have Sohcahtoa. And what this tells us is, so tells us that sine is equal to opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. It's telling us. And this won't make a lot of sense just yet. I'll do it a little bit more detail in a second. And then cosine is equal to adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then you finally have tangent. You have tangent. Tangent is equal to opposite over adjacent. Opposite over adjacent. So you're probably saying, hey, Sal, what is this, all this opposite, hypotenuse, adjacent? What are we talking about? Well, let's take an angle here. Let's take an angle here. Let's say that this angle right over here. This angle right over here is theta, between the side of length 4 and the side of length 5. This angle right here is theta. So let's figure out what the sine of theta, the cosine of theta, and what the tangent of theta are. So if we want to first focus on the sine of theta, we just have to remember Sohcahtoa. Sohcahtoa. Sine is opposite over hypotenuse. So sine of theta is equal to the opposite. So what's the opposite side to the angle? So this is our angle right here. The opposite side, if you just go the opposite side, so not one of the sides that are kind of adjacent to the angle, the opposite side is the 3. If you're just it's opening onto that 3. So the opposite side is 3. And then what's the hypotenuse? The hypotenuse, well, we already know the hypotenuse here is 5. So it's 3 over 5. The sine of theta is 3/5. So someone says, hey, what's the sine of that? It's 3/5. And I'm going to show you in a second that the sine of theta, if this angle is a certain angle, it's always going to be 3/5. The ratio of the opposite to the hypotenuse is always going to be the same, even if the actual triangle were a larger triangle or a smaller one. So I'll show you that in a second. But let's go through all of the trig functions. Let's think about what the cosine. Let's think about what the cosine of theta is. Cosine is adjacent over hypotenuse. So remember, this let me label them. we already figured out that the 3 was the opposite side. This is the opposite side. And only when we're talking about this angle. When you talk about this angle, this side is opposite to it. When you talk about this angle, this 4 side is adjacent to it. It's one of the sides that kind of make up that kind of form the vertex here. So this right here is an adjacent side. Adjacent. And I want to be very clear. This only applies to this angle. If we were talking about that angle, then this green side would be opposite, and this yellow side would be adjacent. But we're just focusing on this angle right over here. So cosine of this angle, we hear about adjacent. Well, the adjacent side to this angle is 4. So it is adjacent over the hypotenuse. It's the adjacent, which is 4, over the hypotenuse. 4 over 5. Now let's do the tangent. Let's do the tangent. The tangent of theta. Opposite over adjacent. The opposite side is 3. The opposite side is 3. What is the adjacent side? We already figured that out. The adjacent side is 4. So knowing the sides of this right triangle, we were able to figure out the major trig ratios. And we'll see there are other trig ratios, but they can all be derived from these 3 basic trig functions. Now, let's think about another angle in this triangle. And I'll redraw it just because my triangle is getting a little bit messy. So let's redraw the exact same triangle. The exact same triangle. And once again, the lengths of this triangle are, we have length 4 there. We have length 3 there. We have length 5 there. The last example, we used this theta. But let's do another angle. Let's do another angle up here. Let's do another angle up here. And let's call this angle, I don't know, I'll think of something, a random Greek letter. So let's say it's xi. I know it's a little bit bizarre. Theta is what you normally use, but since I already used theta, let's use xi. Actually, even instead of xi, let me just simplify it. Let me call this angle x. Let's call that angle x. So let's figure out the trig functions for that angle x. So we have sine of x is going to be equal to what? Well, sine is opposite over hypotenuse. So what side is opposite to x? Well, it opens onto this 4. It opens onto the 4. So in this context, this is now the opposite. This is now the opposite side. Remember, 4 was adjacent to this theta, but it's opposite to x. So it's going to be 4 over, now what's the hypotenuse? Well, the hypotenuse is going to be the same regardless of which angle you pick. So the hypotenuse is now going to be 5. So it's 4/5. Now let's do another one. What is the cosine? What is the cosine of x? So cosine is adjacent over hypotenuse. What side is adjacent to x? That's not the hypotenuse. You have the hypotenuse here. Well, the 3 side. It's one of the sides that forms the vertex that x is at, and it's not the hypotenuse, so this is the adjacent side. That is adjacent, so it's equal to 3 over the hypotenuse. The hypotenuse is 5. And then finally, the tangent. We want to figure out the tangent of x. Tangent is opposite over adjacent. Sohcahtoa. Tangent is opposite over adjacent. Opposite over adjacent. The opposite side is 4. I want to do it in that blue color. The opposite side is 4, and the adjacent side is 3. And we're done. In the next video, I'll do a ton of more examples of this, just so we really get a feel for it. But I'll leave you thinking of what happens when these angles start to approach 90 degrees, or how could they even get larger than 90 degrees? And what we're going to see is that this definition, the Sohcahtoa definition, takes us a long way for angles that are between 0 and 90 degrees, or that are less than 90 degrees. But they kind of start to mess up really at the boundaries. And we're going to introduce a new definition that's kind of derived from the Sohcahtoa definition for finding the sine, cosine, and tangent of really any angle.